everybody, this is Derek Demeter, Planetarium Director at the M. O. Buehler Planetarium at Seminole State College, and coming back at you with another video of our Seminole Space Science series. And today we're going to be talking about these tiny little objects in our solar system we call asteroids, comets, meteoroids, and we're going to learn about the science behind them as well as what we as humanity can utilize, things like mining and such, that will help better humanity here on Earth. And joining me today, we of course have my colleague Justin Cirillo. And Justin, do you think we're in the right attire to go exploring in outer space?
You know, we're a little too business casual. I think we need some mining outfits.
That's right. I think we need to get some space suits on. So how about we do a quick costume change and then we'll get on with exploring.
Let's do it.
Let's do it. All right. Here we go. Are you ready? And a count of 3, 2, 1. Here we go. 3, 2, 1. All right. We are ready to roll. Are you ready for this?
Much better.
All right.
Much
Let's
better.
go. Let's take a look. All right. So, asteroids, meteoroids, comets. This is all essentially the leftover junk in our solar system, right, Justin?
Yeah, some of the oldest materials in our solar system. When you look at some of these objects, I mean, how old are we talking here?
Oh, okay. This is a little heavier than I thought. This is actually an iron meteorite, and these meteorites are 3 billion years old. That's billion with the B. So this is a pretty old piece of material, and this, if you get enough of this, you get a planet from it. Of course, all the iron cores and mantles of planets like Earth would have formed from material like this, these type of things. But we also have this stuff called, it kind of almost looks like a piece of charcoal. This is a carbonaceous chondrite. And a carbonaceous chondrite is a piece of between organic molecules, which are basically the building blocks of us, and silicas, which we find a lot here on Earth. All the stuff that makes up planets are in these little pieces of rock.
Now, Derek,
cool.
you get phone calls all the time from people that say that they might have a meteorite. What would you tell our audience would be some of the things to look for if you think you might have one?
Well, weight is one of them. So, for example, this iron meteorite, this thing is weighty. The other thing is that it doesn't have a really definite shape. If you look at this, you can see as it entered the Earth's atmosphere, it got smelted, it got super heated up, it had a lot of force on it, so you get this really irregular shape to it. And a lot of people actually, when they find a meteorite, they think it's a piece of aluminum can or something that just doesn't, it's a piece of trash. They don't think it's a meteorite. So that's another thing too, is the irregular shape. It doesn't have a nice uniform shape. Usually when you find iron, slag, and things like that, it has more of a usual shape. Weight does it, and also weird location. So for example, if you found this in Florida, which is where we're located, that's a pretty high chance it's going to be a meteorite, because we don't generally have big chunks of iron sitting around everywhere. So those are some of the key things. You can also do some chemical tests. You can take it to a nearby university or somebody who does analysis on meteorites, and they can also look at it too to make sure 100% that it's a meteorite.
Well, and magnetism is a good clue.
You're right. Magnetism is another thing, but magnetism can also, you have lodestone, you have other types of rocks here on Earth that are magnetic. We call them ferromagnetic. So that isn't always the clue that gives you that it's a meteorite. So you have to do a couple of extra tests as well.
Absolutely amazing. And when you cut into these things, we have samples here where you can actually see the different nickels, the irons inside.
That's
of
right.
these
So you
meteorites.
have, this is a palisite meteorite, and it actually contains nickel, iron, but it also contains pieces of silica, and it actually forms this beautiful peridot. It's a gemstone that we have here on Earth that's actually embedded in the material. So you have this mixture of iron, of nickel, of silicas, things again that are the building blocks of planets like Earth in our solar system. And Justin, can you talk about this thing here? Of course, you get enough of this material, but not enough to make a planet. You can get an asteroid. And so this is an asteroid right here.
One of our friends did a tremendous job putting this together. This is a 3D printed model of the asteroid Vesta. And this would be in life size about the equivalent of 2 Florida widths. In diameter, so a pretty good sized chunk of metal. And this is in the asteroid belt. And the asteroid belt, of course, is this area of our solar system between Mars and Jupiter that is holding millions, maybe billions of pieces of asteroids. And this is a sizable asteroid in the asteroid belt. These are fantastic objects to study. The Dawn spacecraft spent many, many years orbiting around this asteroid, taking detailed imagery of the surface, trying to understand the makeup and what happens to asteroids over time. And as they get closer to Earth, they break up, and some of them enter into our atmosphere and become meteorites. And that's the samples that we have here.
Yeah.
So an asteroid, a meteor, a meteorite, we're just breaking down larger pieces of
But
metal.
sometimes you have pieces that are not made up of rocky material, but of ices, very cold material, ices, water, other ingredients as well, alcohols, organic molecules. These are found way out in the depths of the solar system. We call them comets. And just recently, we had a very, very cool comet class from a comet called Comet Neowise F3 2020. And this is a very, very, very cool comet pass. It was actually very close to the Earth, only about 65 million miles from the Earth, and we got to see an amazing tail. And I got a chance to take some really cool pictures here, and you'll see here, get this beautiful tail pattern, big, dense, what we call coma, which is ice that's basically vaporizing off the main part of the comet we call the nucleus. So this is an amazing thing, and we think that a lot of the ingredients for life actually came from the outer solar system and were brought in from these comets over time. So who knows, maybe life here on Earth actually started out way out in the depths of outer space. But you know, one of the things too that we can do is we can go mining. We're gonna go mine?
Yeah, let's mine.
Yeah, let's go mine. Yeah, let's go mine.
Asteroids.
Yeah, let's go mine. Well, actually, we don't really need this, and we're not gonna use this if we're actually gonna go mining for asteroids. But Justin, there are some incredible missions that are going, or that are currently at little objects like these asteroids. And what are they really doing there? What's the purpose? Why do we want to send these things out there in space?
Well, there's a twofold approach. One is an asteroid redirect mission. How important would it be if we saw that an asteroid was on a collision course or even near Earth? We would want to maybe interrupt that collision, right? And that's exactly what NASA scientists are doing. That's exactly what European scientists are doing, and that's exactly what Japanese scientists are doing. We have visited multiple comets, multiple asteroids, and we have taken samples from these asteroids so that we can understand how they're built. This isn't like Hollywood movies where Bruce Willis goes up and puts a nuclear weapon inside the asteroid.
Definitely
and
something you don't want to do.
blows it up into thousands of pieces, because then you just have thousands of objects potentially striking Earth. But if you can just nudge that asteroid in its orbit, well, then you just nudge it enough to move it out of contact with the Earth. The other reason is the resources. These asteroids are filled with precious metals that can be used here on Earth.
So usually when we get metals here on Earth, we have to get them from, well, volcanic eruptions, cataclysmic events like basically pieces of Earth's crust that are getting uplifted and depositing these very hot rock up into the seams, we call them veins. It's actually hard to get this kind of stuff here on Earth. But on asteroids, you can find asteroids made of solid iron or nickel or titanium or even gold. And this is very exciting, because if you could harness the ability to capture one of these small asteroids and bring it either to Earth, close to Earth, or just send a mission out there to collect material, you can make accessing this kind of stuff much easier, especially with building for future missions as well. So that's really exciting stuff, and there's missions going up all the time. They're studying these little objects. I think these are some of the most fascinating things in our solar system that really give us a insight on our development here in the solar system, and what we could do as far as building a spacefaring world where we have humans dispersed all throughout the solar system. This is a very exciting time. And what we're hoping to do is we're hoping to maybe connect with some researchers to continue other videos where we'll get a chance to do some interviews on some of the latest research and developments on this. So be sure to subscribe to our channel channel, and also to follow us on our social media pages, because we're going to have some really exciting videos in the future where we'll continue exploring the avenues behind asteroid mining, research on these objects, and maybe even get a chance to talk to some of these principal scientists that are on these missions. So I hope that you enjoyed this video today, and of course, as I mentioned before, be sure to hit the thumbs up if you like this video, and also be sure to subscribe to notifications about any future videos that we have going on. Until then, Justin, I think it's time for us to head back down to Earth, right? Because we got a lot of other stuff to do. So we'll see you next time in another video, and have a great day, everybody.